Hi guys, so today we're going to start looking at the unit of statistics. Statistics is basically studying numerical information, and that we use information that we gather from people or from groups of things, and we use it to describe groups and make predictions. So what you do is you take a group of people, for instance, let's say you want to know, a magazine company wants to know what's the average income of their readers. They take a sample of their readers, a smaller group of the population. They figure out what the average is, they figure out other numerical data called statistics, and then they use what they found to then generalize to everybody, to the what's called the population. So you have some definitions. The population is the entire collection of people being studied, and then the sample is a group that's being selected from the population to represent everyone, because you can't possibly test on everybody. So when you create a sample, some basic guidelines are that I'm going through this table here. The sample has to be fair. It has to reflect everybody. So you can't, if I wanted to know about 8th graders in general in the United States, I wouldn't just take a group of 8th graders from Scarsdale. I want to reflect everybody in the population. It has to, number 2, it has to contain a reasonable number of items. So you can't only test something on, say, 10 people. It has to be a large number of people so that it could then be generalized to everybody. There's an example of that. If just because a medicine works on 1 or 2 patients doesn't mean that it's necessarily effective for a large group of people. And random selection should be used. So you should always try to eliminate bias, or where the results are slanted towards one group or another, by randomly selecting people to make sure that everything's fair. So a lot of this is going to be me talking and not so much you doing math, but we collect data, and then we organize that data into charts, and then we draw conclusions from this data. And so what we look at in the current unit is how we organize the data. So you guys will be looking at frequency tables, histograms, stem and leaf plots, dot plots, box and whisker plots. These are all ways of organizing the information. And specifically, we'll be organizing univariate data. So univariate, I'm kind of going out of order, but univariate means that we're studying one variable, or we're measuring one variable, for example, travel time. Whereas bivariate data measures 2 variables. Like if you ask somebody how much ice cream they sell in their store and the temperature on that day, that's 2 measures of data. So we're going to be focusing on one measure of data for now. And also going back up to the top, qualitative and quantitative data, you guys have looked at this in science, is that qualitative data asks people about categories of things, like is the food excellent, satisfactory, or poor at a restaurant? Whereas quantitative measures through numbers. There's some sort of unit of measurement. So, for example, a restaurant keeping track of the number of dishes sold. That's numerical and quantitative. So the first type of way of organizing information we're going to look at is called the frequency table. A frequency table here represents student absences in 1 month for a class of 20 students. So the way you would look at this is that one student was absent 0 times, another student was absent 3 times, another one was absent 1 time. So you organize this by creating a frequency table. So there's a column that tells you the frequency. So how many people were absent 0 times? There was 1, 2, 3, 4, 5, 6, 7. There were 7. How many people were absent 1 time? 1, 2, 3, 4, 5. And then sometimes you have this additional column in the middle called the tally, which is just literally a tally of that number. So this would be 7, this would be 5, etc. Okay, I'm not going to fill out the whole table. Sometimes frequency tables have intervals. Intervals are ways of grouping the information so that it's easier to look at. So instead of having a row just for people who scored a 99 and a row for people who scored 98, 97, it's better to group the values. But each group has to contain the same number. So like 91 to 100 has 10 numbers in that group. 81 to 90 has to also have 10 numbers. This one has to have 10 numbers. That's the rule for creating the frequency table with intervals. And so you do the same thing here, only here you're looking at, well, how many people scored from 91 to 100? And you would count them up and put them in the frequency. And then if there's a tally, fill out the tally also. I'm not going to fill out the table. I'm just going through this overall. Here's an example of a frequency table. This one doesn't have a tally column, so it's telling you, for instance, if you were to read this, it's telling you the frequency is how many people. So this is telling you that 550 people earn a salary between $44,000 and $54,000. Okay, that's what they're telling you with the 550 frequency. Frequency tables get graphed into what are called histograms. A histogram looks like what you see in front of you, only it looks like a bar graph, but it's not a bar graph because your bars are touching one another. Bars are touching. That's what makes it different. Also, the reason why they're touching is that you have numerical intervals here. Whereas a bar graph is categories. So a bar graph would look at like, well, how many people like pizza? And that's one bar. And then how many people like hamburgers? That's another bar. But this is continuous. This is like the numbers connect to each other. So the bars have to connect to each other. Okay, when you draw your own histogram, you don't need to shade in any bars or anything. This is just for effect when you're working with a computer. Here's another example of a histogram. Notice that if you're creating a histogram, that if your first value does not start at 0, that you need to leave a little space here, and you should put what's called a break. A break is a little jagged line there to indicate that you're skipping from 0 to a certain value. Another type of way of organizing data is stem and leaf plots. A stem and leaf plot looks like this. What you do is you basically connect the stem to the leaves. So this reads 44, 46, 47, 49. 44, 46, 47, 49, etc., etc. This is telling you there's no 50. There's no numbers in the 50s, 63, 64, 66, and so on. Another way of organizing information is called a dot plot. A dot plot puts dots, or sometimes you'll see X's in places of dots, and it tells you the frequency. So like how many minutes it took people to eat breakfast. So it took 1, 2, 3, 4, 5 people 5 minutes to eat breakfast. It took 2 people 8 minutes to eat breakfast. Measures of central tendency. These are the mean, the median, and the mode, which you've learned about in the past. They're basically, we want to find ways to calculate the middle. We want to know what the average is. So there are 3 different types of middles or averages, or what we call central measures of central tendency. The mean is where you add all the values up and divide by the total frequency, the number of numbers. The median is the middle value. But remember that your values have to be ordered from least to greatest, or greatest to least. They have to be ordered. And the mode is the one with the highest number of times that it appears, which we call the highest frequency. The value with the highest frequency, the one that appears the most. So if you had, for example, the list of numbers below, to find the mean, I'm not going to actually do it, but I would add all these values, 5 plus 15, plus 10, plus 15, plus 5, plus 10, plus 10, plus 20, plus 25, plus 15. I would add all that, and then I would divide it by the frequency, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And whatever that comes out to be, that's my mean. My median, I would put them in order first. So let's see, I have 5, 5, 10, 10, 10, 15, 15, 15, 20, and 25. So you guys are used to doing this where you do the crossouts, but we're going to learn a different way of doing it. But you would cross out, you guys go like this till you get to the middle. When there are 2 middle numbers, you find the average of the 2. You find the mean. You add them and divide by 2. So you're going to end up getting 12.5 here. And the mode is the number with the highest frequency, the one that appears the most. It looks like we have 3 10s and we have 3 15s. So there are 2 modes. We call that bimodal. Bimodal means 2 modes, 10 and 15. We're going to be figuring out median for large number sets. So after this, we're going to figure out the median for like a group of like 47 numbers. So you won't be able to do the crossouts, and we'll talk about a different strategy for doing that. The mean is sensitive to outliers. That's a really important concept. That means that if there's an outlier, a really, really high or low number, like if I had one student who scored a 45 on a test, that's going to affect my mean a lot more than it's going to affect my median or my mode. So here's an example. In the first data set, the mean is 83.4, the median is 84. Those are really close to each other. In the second data set, the 65, the kid who got the 65 got replaced with a 0. So maybe he cheated or something, got a 0. All of a sudden, my mean drops to 79. Whereas my median is 84. So it just goes to show you that the mean is not always representative of everybody. So you might want to use median instead if you have an outlier. And we're going to look at some mean word problems. The mean of Nat's first 3 tests this quarter is 89. If he scores 86 on the next test, what will be his final average? So in this problem, I'm going to have to continue on to a different video before this gets too long. All right.